metalloids. So now we will see about metals and their properties alone. Metals are the most common things that you see around in your home. The plate that you eat, the vessel that is being used to cook food, the window grills, everything is metal. Here we are going to see the physical properties of metals. The first one is physical state. Physical state is what you say when you look at a metal. You say they are solids. So the first property tells you that the metals are solids at room temperature. But certain other metals like rubidium, francium, gallium, they melt above the room temperature. The second property is hard. So when you say metals are solids, it is obvious that they are hard. They cannot be broken that easily, right? Certain metals like sodium and potassium are an exception from this case. Sodium, they are less hard that they can be easily cut with a knife or with a coin edge. So this will make you more clear. So here that is the sodium metal being cut with a knife. That is so easily done, just like that, as a piece of cake. The next property is luster. So this comes from a Latin word again, lux, meaning light. All the metals, when they undergo polishing, they get a shining surface like this. This is how they shine when they are being polished. So when you buy a new vessel also, it will be more shinier, right? That is all because of polishing. So metals, they become shinier or they are lustrous when they are polished. The next property is density. So when I say metals are solid, metals are harder, obviously it will have some weight. That weight is called density. So all the metals are denser except sodium and potassium. So because sodium can be easily cut by a knife, so it will not have that much weight, right? So sodium and potassium are an exception under this property. The next one is melting point and boiling point. So I told you metals are solids at room temperature. So they will have a particular temperature where they melt. So when you take a matchstick near your window grill and you say it will melt, no, it will not. You can also see the gold that they are used when they are made into a jewelry. They will be burnt or they will be kept in a very high temperature so that it melts and it will be made into several shapes and forms. So every metal has its own melting point and boiling point. The next property is tensile strength. So tensile, you say tense. Tense here is the force that is being applied on the metal so that they can be pulled apart. So which metal has a very high tensile strength will be very strong. So here I say that iron has a very good tensile strength. That is why it is being used in the construction of railway tracks and also in bridges. Whereas other materials like zinc, arsenic are the exceptions under this property. The next topic is malleability. Malleability is the quality that can be used to shape into something else without breaking. Okay, so here imagine a clay. You take a piece of clay and you make it into different shapes and forms. You just do that easily, right? That is called malleability of a metal. So here you need not break a metal. It can just be melted into different shapes and forms. And it is also related to plasticity. So what is plasticity here? You see a rubber band, you just pull it out and it just comes back to its original shape. That is elasticity. Plasticity here, once the metal is deformed into another shape, it will never go back at the original form. That is called plasticity. Next is ductility. Ductility is where you apply more and more number of force. I'm going to hammer in the sense I'm going to beat it nicely so that it will change from the original shape to the desired form I want. So the copper wires, all the electricity connections are made with copper wires, right? So how it is being made as a very thin wire, that is called the ductility. That is changing its shape to the desired form. It can be made into coils, the wires, okay, whereas in malleability it can be made into plates or thin sheets. So example for malleability metal will be aluminium, where you have aluminium foil paper you have, or aluminium sheets you have. For ductility, copper will be the best example, that is being made as rolled into wire. So malleable means able to be flattened into a thin sheet or foil. Ductile means it can be pulled into a long thin wire. So all the metals, they have both the property of malleable and ductility. Okay. So the next property is conductivity. So all the metals are good conductors of electricity. Copper, silver, aluminium, everything are good conductors of electricity. The next one will be sonorous. Sono means sound. So whenever I hit a metal, I hear a sound. So that property will make it to be used as bell in temples. Uses of metals. So where are these metals used? First one is iron, which has a very good tensile strength. That is why it is used in the construction of railway tracks, bridges, etc. Next is silver and gold, which is used in making of jewelries. Copper is used in electric wires, and also we have coins, the 10 rupees coins. When you see, you have copper in it. Aluminium is the lightest metal and it is used in the making of aircraft. So when you see aeroplanes, the body of it is made up of aluminium metal because it is very light and it will be easy to fly high. Mercury, you find it in thermometers, and lead is used in batteries. The phone battery, the laptop battery, everything you have lead in it. Okay, so with this today's class is over. So kindly go through the same topics which is being taught today in the e-copy of your textbooks, and if you have any valuable doubts, ping me. Thank you, children.